Hello students, today we'll understand the concept of calorimetry. Okay, we're starting chapter 11. Let's try to understand the concept of calorimetry. Okay, so first of all, let's understand the concept of heat. You know that each substance is made of molecules, and these molecules are in random motion, and these molecules are attracted by some force, attractive force. Okay, and because of this random motion of the molecules, these molecules possess kinetic energy, and because of the attractive force between the molecules, they have potential energy. Okay, so molecules possess both potential energy as well as kinetic energy, and some of this potential energy and kinetic energy of the molecules is called internal energy. So in a way we can say that all of the substance possess internal energy because they have both kinetic energy as well as potential energy. Okay, kinetic energy due to its random motion of molecules, potential energy is due to the attractive force between the molecules. Okay, now we can say hot body has more internal energy compared to cold body. Why? Because when the body is hot, it has more random motion. Okay, because of that, it has more internal energy. So you can say the hot body has more internal energy compared to the cold body. And when two bodies, one hot body and one cold body, are in contact with each other, then the heat will start flowing from the hot body to the cold body. So what is heat? Heat is a kind of energy. It's a form of energy which flows from the hot body to the cold body. Okay. So heat is a form of energy which flows from hot body to cold body when they are made in contact with each other. Okay, they are brought in contact with each other. What is the SI unit of heat? SI unit of heat is joule. That you know because the heat is also one of the energies, so it has the same energy as it has the same unit as energy. The other units of heat is calorie. Okay, and there is a relation with calorie and joule also. 1 calorie equals to 4.186 joule, or nearly equals to 4.2 joule. Okay, now let's understand what is 1 calorie. Okay, 1 calorie is equal to the amount of heat energy given to 1 gram of water to raise the temperature of that 1 gram of water by 1 degree Celsius. Okay, if I have a 1 gram of water and if I want to raise the temperature of this 1 gram of water by 1 degree Celsius, then whatever the amount of heat which is given, that amount of heat is equal to 1 calorie. Okay, and it is in, suppose I have 1 gram of water and initial temperature of that 1 gram of water is 10 degrees Celsius. Okay, so and I'm adding heat to it to increase the temperature by 11 degrees Celsius, to increase the temperature to 11 degrees Celsius. Okay, because here I'm increasing the temperature by 1 degree Celsius, 10 to 11. So whatever the amount of heat I give, that amount of heat I can call 1 calorie. Okay, suppose I have 1 gram of water and initial temperature of that 1 gram of water is 15 degrees Celsius, and I want to increase it to 16 degrees Celsius by 1 degree. So whatever the amount of heat I should give, by definition it should be equal to 1 calorie. But it is seen that from 10 to 11 degrees Celsius, to increase the temperature of 1 gram of water by 1 degree Celsius, whatever the amount of heat you give to the water is not equal to the amount of heat that you have to give when the initial temperature of the water is 15 degrees Celsius and you want to increase the temperature by 16 degrees Celsius. You want to increase the temperature to 16 degrees Celsius. That is by 1 degree Celsius only. So it means that the amount of heat that you are giving to 1 gram of water also depends upon the initial temperature. For different initial temperature, even though you are increasing the temperature by 1 degree Celsius only, the different amount of heat is needed. Okay, from 10 to 11, 1 gram of water only, whatever the amount of heat is needed is not same. Okay, when 1 gram of water which is at 15 degrees Celsius, and if you want to increase the temperature of that 1 gram of water to 16 degrees Celsius by 1 degree Celsius only, whatever the amount of heat which is given is not being same. That means the 1 calorie definition we have to change. We have to also mention the initial temperature. So the standard definition of 1 calorie is that the amount of heat which is required to increase the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius. So here also increases 1 degree Celsius only, but here we have defined the initial temperature from 14.5 to 15.5 degrees Celsius. Whatever the amount of heat which is given to 1 gram of water, that we can call as 1 calorie. Okay, so calorie is another unit of heat which is also very much used. Okay, how much calories burnt in the body. Okay, that in commercial use, daily use, we use the unit of heat. Okay, so 1 calorie equals to, there's a relation between that, 4.186 joule I told you before, nearly 4.2 joule. Okay, and 1 kilocalorie equals to 1000 calorie. That 1 kilocalorie means 1000 calorie. Now let's understand the concept of temperature. What is temperature? Temperature determines the coldness and hotness of a body. It determines the thermostat of the body, how hot or how cold a body is. Okay, that can be easily determined by the temperature. And if you have two body, one hot body and one cold body, that means a body at higher temperature and another body with lower temperature, and if we bring them in contact, then heat flows from the hot body to the cold body. That means heat flows from the body at higher temperature to the body at lower temperature if I bring them in contact. So temperature also determines the direction of the heat flow. Okay, so we can define the temperature is a parameter which measures the thermostat of the body. That means which tells us how hot or the cold the body is. And secondly, it also determines the direction of the heat flow, because heat always flows from the hot body to the cold body. Suppose we have two bodies, then what happens? The heat starts flowing from the hot body to the cold body until when? Until the temperature of the both the body becomes equal. Okay, temperature of the both body becomes equal. Suppose this body has temperature 15 degrees Celsius and this body has temperature 5 degrees Celsius. If I bring them in contact, then the heat start flowing from this body to this body. Okay, and let's say they attain the common temperature 10 degrees Celsius. Then this body starts losing its temperature, this body starts gaining its temperature. So from 15 to it moved to 10, from 5 to it moved to 10. So once it reaches 10 degrees Celsius, both of the body becomes 10 degrees Celsius, then there will be no heat flow. Okay, so the heat will only flow as long as there is a temperature difference between the body. Okay, so but can I say that if the two bodies have the same temperature, that the heat contained by the both body will be same? Okay, can I say that? I can think out. Okay, so even if the two bodies have same temperature, it doesn't mean they have the same amount of heat also, heat energy also. Okay, because the amount of heat contained by a body doesn't only depend upon the temperature. That's the main reason. Okay, that means if you have two bodies, okay, if you give the same amount of heat to two different bodies, then it doesn't mean that the rising temperature in both the bodies will be same. Okay, we have iron, we have a copper, and you give the same amount of heat to both iron and copper, the rising temperature in iron and rising temperature in copper will not be the same. Okay, so you have to keep in mind, two bodies having the same temperature doesn't mean they have the same heat content. Okay, and heat will not flow between the two bodies if I bring them in contact if they have the same temperature. Okay, it doesn't mean this doesn't mean that the heat contained by both the bodies is same. Okay, even if the heat contained by the two bodies are different, the heat will not flow. Okay, it will only flow if the temperature is same. So keep that in mind. Okay, it is confusing if you don't understand it. They might ask you the questions from here. So temperature has to be same for not exchanging the heat between the bodies. Okay, what is the unit of temperature? The SI unit of temperature is Kelvin. Remember, in Kelvin you don't write degree, just 100 Kelvin, 200 Kelvin, like this. Okay, and the other unit of heat is Celsius. Okay, Fahrenheit, you know that. How can we convert the Celsius into Kelvin? How can we convert 1 degree Celsius into Kelvin? You know the formula. You have to add 273 to convert Celsius into Kelvin. So 1 degree Celsius is equal to 1 plus 273, which is 283 Kelvin. Okay, 0 degree Celsius equals to 0 plus 273, which is 273 Kelvin. Okay, and 100 degrees Celsius equals to what? 100 plus 273, that is equal to 373 Kelvin. Okay, so 0 equals to 273 Kelvin, 100 equals to 373 Kelvin. So between 0 to 100, how many divisions? Between 0 to 100, 100 divisions. And between 273 to 373, how many divisions? From 273 to 373, 100 division only. So divisions is same, only the starting point is different. Celsius is from 0 to 100, but Kelvin is from 273 to 373. Okay, number of divisions is same, it is 100 only. Okay, therefore we can say that rise in the temperature difference in both the situation is same. Okay, we'll talk about that in details in numericals. Suppose I say the body has a temperature 20 degrees Celsius, and after a while the temperature increased to 25 degrees Celsius. So from 20 to 25. So what is the rise in temperature? Rise in temperature is 5 degrees Celsius. And Kelvin also, rise in temperature will be 5 Kelvin only. Okay, because the number of divisions is same, both in 100. Okay, so whenever you have to, suppose you just have 0 degrees Celsius, and if you want to convert into Kelvin, then you have to add 273 to convert into Kelvin. But if you have a change in temperature, okay, so it's 5 degrees Celsius change in temperature, then if you want to convert into Kelvin, it will become 5 Kelvin only. Okay, because change in temperature in Celsius and change in temperature in Kelvin is same, because both of them have same division, 100 divisions. Keep that in mind. Okay, while doing the numericals, I'll explain that to you while doing the numericals also. There it will become more clear. So now let's try to understand the factors which affect the quantity of heat absorbed to increase the temperature of the body. So what are the factors on which the quantity of heat absorbed to increase the temperature of the body depends? So there are two factors on which it depends. First factor is mass of the body. Suppose we have 1 kg of water, and 1 kg of water I want to increase the temperature of this 1 kg of water by 1 degree Celsius. In that situation I need 1 kilocalorie heat energy, and now I have 2 kg of water and I want to raise the temperature by 1 degree Celsius only, and the heat energy which I need is 2 kilocalorie, double the previous situation. That means if you have same substance, that is water only, and if you want to increase the temperature of the same substance by the same temperature only, okay, then if to double the mass, then the heat energy which is needed also becomes double. That means the amount of heat which is needed to raise the temperature of any substance is directly proportional to the mass of the body. Okay, for 1 kg it is 1 kilocalorie, for 2 kg it is 2 kilocalorie. Okay, so it is directly proportional to the mass of the body. More is the mass of the body, more is the amount of heat needed to raise the temperature. Okay, second factors on which it depends is the increase in temperature of the body. Now let's say we have 1 kg of water, and I want to increase the temperature of 1 kg of water by 1 degree Celsius. Then the amount of heat which is needed would be 1 kilocalorie. Now I have 1 kg of water only, but I want to increase the temperature by 2 degrees Celsius. Okay, in that situation the amount of heat which is needed is 2 kilocalorie. So from here also we can conclude that more is the temperature increase needed, more is the amount of heat required. Okay, so amount of heat to raise the temperature of the body is directly amount of heat needed to raise the temperature of the body is directly proportional to the change in temperature of the body, is directly proportional to the rise in temperature of the body. Okay, so keep that in mind. The third factors on which the amount of heat which is needed to raise the temperature of the body depend is the material of the body, also you can say, or the substance of the body. Suppose I have 1 kg of water and 1 kg of this one copper only. Okay, and I want to heat the temperature of this, I want to increase the temperature of this copper and water by 1 degree Celsius. Then the amount of heat which is absorbed by the water is almost 10 times than the amount of heat which is absorbed by the copper. That means if you want to increase the temperature of water by 1 degree Celsius and temperature of copper by 1 degree Celsius, then whatever the amount of heat which you are giving to the water is 10 times the amount of heat which you are giving to the copper. Okay, copper it is very less amount of heat. For water it is 10 times the amount of heat. So from here we can conclude that amount of heat which is needed to raise the temperature of the body also depends upon the substance of the body. Okay, water molecules are made of, water substance is made of different molecules, and copper substance are made of different molecules. Because of that there is a difference in the amount of heat needed to raise the temperature. Okay, so overall we can say Q is proportional to the mass of the body, Q is proportional to the temperature change in the body, and the substance of the body we can call specific heat capacity. What is specific heat capacity? We are going to talk about it, but substance of the body is actually defined by the specific capacity, C. Okay, we'll talk about this details. So Q is proportional to M, Q is proportional to delta T, and Q is proportional to C, which is the specific heat capacity. The amount of heat which is needed to raise the temperature of the body depends upon substance of the body or the material of the body also, and that has a name. Okay, we can call it specific heat capacity of the body, C, small c, because the specific heat capacity separates the copper from water. Okay, specific heat capacity is the property of the substance. Okay, so what is specific heat capacity? We're going to talk about this, but just for now we understood that Q, the amount of heat which is needed to raise the temperature of the body, is directly proportional to the mass of the body, is directly proportional to the temperature change in the body, and if we write it together, then Q is proportional to M and delta T, and if I remove the proportionality sign, then Q is equals to CMT. That C is the specific heat capacity. In this case, it is the proportionality constant also. Okay, specific capacity for a particular substance is one value, it's one number. Okay, for water it is one number, for copper it is one number. Okay, so it is different from material to material, it is different from substance to substance. This specific heat capacity is the property of the body. Because of that only, the amount of heat which is needed to raise the temperature by the same degree is different for copper and water and for different substance. Okay, so let's talk about this specific heat capacity. Before I go into specific heat capacity, let's try to understand what is heat capacity first. Okay, you have seen that for different substance, for just now you saw the example of water and copper, that the amount of heat which is you give to, if you give the same amount of heat to water and copper, the rise in temperature in both the situations is different. So it's because of something, that property we call it heat capacity. What is heat capacity? Heat capacity of a body is defined as the amount of heat energy which is required to raise the temperature by 1 degree Celsius or 1 Kelvin. So amount of heat which is required to raise the temperature by 1 degree Celsius or 1 Kelvin. I said 1 degree Celsius or 1 Kelvin because change in temperature in both Celsius and Kelvin is same. Okay, only the one value of temperature is different. Change is same. Both 1 degree Celsius by 1 Kelvin is same. Okay, so because of that, so heat capacity, just now you understood that is the amount of heat which is required to raise the temperature of any substance by 1 degree Celsius. Okay, for copper it is one value, for iron it is another value. Okay, that's there. So if Q is the amount of heat which is needed to raise the temperature of any substance by delta T degrees Celsius, then heat capacity is defined as delta Q by delta T. Okay, it's the amount of heat required per unit change in temperature. So that can be defined as heat capacity. Okay, C prime equals to Q by delta T. You can see it on page number 263. Okay, C prime equals to Q divided by delta T. That is heat capacity. And what is the unit of heat capacity? Q is equals to unit of SI unit of Q is joule, SI unit of temperature is Kelvin, so SI unit is joule per Kelvin. Okay, so there are other units of obviously this heat capacity also, joule per degree Celsius also we can say, but it is not the SI unit, but it is the conversion unit, joule per degree Celsius or calorie per degree Celsius, kilocalorie per degree Celsius. Okay, other units also you can define in terms of the, because of the formula you can easily find it out. It is Q by T, so calorie per degree Celsius is also fine, kilocalorie per degree Celsius is also fine. Okay, so yeah, 1 calorie per Kelvin equals to 4.2 joule per Kelvin, because 1 calorie equals to 4.2 joule. You can always get the relation also. So just now you understand the heat capacity. Okay, now what is specific heat capacity? Specific heat capacity, suppose there's a difference between heat capacity and specific heat capacity. It's a very minor difference. Suppose I have an iron rod, okay, and the mass of this iron rod is suppose 50 gram. Okay, if you want to raise the temperature of the iron rod by 1 degree Celsius, then whatever heat is needed, that is equal to heat capacity. But if I want to find out the standard value of the heat, okay, then what I would do, I will consider 1 kg of iron rod, and whatever is the amount of heat which is needed to raise the temperature of 1 kg of iron rod by 1 degree Celsius, that I can call as specific heat capacity. So specific heat capacity means the amount of heat which is required to raise the temperature of any substance of unit mass by 1 degree Celsius. Similarly for copper, 1 kg of copper, what is the amount of heat which is needed to raise the temperature of 1 kg of copper by 1 degree Celsius? I can call as specific heat capacity. Okay, so specific heat capacity is actually the heat capacity per unit mass. For 1 kg mass in SI unit or in Celsius unit, for 1 gram of mass, whatever is the amount of heat which is needed to raise the temperature by 1 degree Celsius, that I can call as specific heat capacity. Okay, so there's a difference between heat capacity and specific heat capacity, and we can say specific heat capacity is equal to heat capacity per unit mass. Okay, so C prime divided by M is equals to small c, which is the specific heat capacity. So we know C prime equals to Q by delta T. Okay, and small c specific heat capacity equals to C prime by delta T. So finally we're getting Q divided by M delta T. As you can see here, over here, C prime is the heat capacity, which is Q divided by delta T. It absorbed per unit rise in temperature, And specific heat capacity is actually the heat capacity per unit mass. No, 11.7 equation you can see. So replacing that, we get specific capacity C equals to Q by delta T divided by M also. Okay, mass of the body. And the specific capacity of the substance is the amount of heat energy required to raise the temperature of unit mass of the body to 1 degree Celsius. So here we are talking about the unit mass in case of specific capacity. That means of 1 kg mass or 1 gram of mass. But in case of heat capacity, it is the amount of heat required to raise the temperature of any mass. Okay, 550 gram, 10 gram, like that. So specific capacity is the more standard one. Okay, because for iron, if you know the specific capacity for iron, that means I know 1 kg of iron, what is the amount of heat which is needed. Okay, which is the standard value. It is one constant value which will not change. So if I know for 1 kg of iron, I can find out for 50 kg also, I can find out for 10 gram also, I can find out for 100 kg also, depending upon what is there. So specific capacity is the more is the standard value, okay, for every different substance. For water, 4180. Okay, for it is 4180 for water. So here we got the formula. We got find a formula C equals to Q divided by M into delta T. So from here Q equals to how much we are getting? Q equals to MC delta T. Q equals to MC delta T we are getting. So what is Q? Q is the amount of heat which is needed to raise the temperature of the body. And M is the mass of the body, C is the specific capacity of the body, delta T is the rising temperature of the body. So from here we can also, before only we have discussed, from here also we can easily find out that Q, the amount of heat which is needed to raise the temperature of the body, depends upon the mass. Is directly proportional to the mass, directly proportional to the rise in temperature. More is the rise in temperature, more will be the heat which should be given, and it is directly proportional to the material or the substance of the body, that is C, which is the specific capacity. Okay, material means specific capacity, because the specific capacity for different material is different. Okay, so based on that, because specific capacity means the amount of heat which is needed to 1 kg to raise the temperature of unit mass of the body by 1 degree Celsius. So which is different for different these bodies. Like it is maximum for water, which is 4180. It's a minimum of lead 130, mercury 139. Okay, lesser is the value of this specific capacity. Good conductor it is, good conductor of heat it is. Okay, because for copper, zinc, only less amount of heat is needed to raise the temperature. Okay, for water it is more amount of heat needed to raise the temperature. Okay, for the same mass.